Hey, it's Professor Dave. Let's talk about solutions.
He knows a lot about the science stuff. Professor Dave explains.
A homogeneous mixture that's in one phase is called a solution. Think of something like table salt in water. If we are talking about a liquid solution, the thing that gets dissolved is called the solute. In this case, that's the salt. And the thing doing the dissolving is called the solvent. Here, that's the water. Solutions tend to retain the properties of the solvent, since solvent particles are typically much more abundant than the solute. We can say that a solute is either soluble or insoluble in a particular solvent, depending on whether it will dissolve in that solvent. Something will dissolve if in doing so it will make favorable intermolecular contacts with solvent particles. In the case of salt, it will dissolve and dissociate so that the sodium ions and chloride ions can make ion-dipole interactions with water molecules. A nonpolar covalent compound will not dissolve in water because without a dipole, it can't make any dipole-dipole interactions with polar water molecules. That's where we get the saying, like dissolves like. Salt water is a strong electrolyte because the formally charged ions in solution can conduct electricity. Weak electrolytes only partially ionize in solution, so they conduct electricity weakly. We can use molecular equations to describe substances that transform in solution, and it will be useful to use subscripts after each compound to show its phase. There's solid, liquid, and gas, and we use the word aqueous to describe ions that dissociate in solution. This is important because sometimes ions come together to form a new compound which may be insoluble in that solvent. In such a case, we will denote that it is in the solid phase, as it will crash out of solution as a precipitate. We can write molecular equations to describe solution chemistry, but we can also use net ionic equations. This summarizes the key transformation by eliminating spectator ions, the ones that just sit in solution and don't do chemistry. To do this, we start by writing the complete ionic equation. This involves splitting the ionic compounds into their respective ions. Just remember the common charges of the ions to include the correct formal charges. Subscripts in the molecular equation become coefficients in the complete ionic equation since all the components are dissociating. Anything that's present on both sides we can cancel out, like an algebra problem. These are the substances that don't do any chemistry. What's left are the two ions that come together to form a solid precipitate, which is a chemical change. This is the net ionic equation. In addition, sometimes we categorize these kinds of reactions as being either synthesis, where two things become one, decomposition, where one thing becomes two, single displacement, where one component swaps out, or double displacement, where two components switch places. This is just good vocabulary to know. Let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials, and as always, feel free to email me, ProfessorDaveExplains@gmail.com.